Good afternoon to everyone. So today I'm going to discuss my topic with the title of open circuit test and short circuit test. So what is the need of open circuit test and short circuit tests? So the open circuit and short circuit test on a transformer is helps to determine the following parameters. So the first one is the parameters of the equivalent circuit. What are the parameters of the equivalent circuit? The first one, that is R naught, X naught, and R naught 1 or R naught 2 and X naught 1 and X naught 2. So second one is the voltage regulation. And the third one is iron loss and copper loss for calculating the efficiency without actual loading of the transformer. Moreover, the power is required to carry out these open circuit and short circuit tests is very low comparing to the load test on a transformer. Here we are discussing open circuit and short circuit test. So what is the main purpose of this open circuit and short circuit means to calculate the following parameters. What are the parameters means? The first one is the parameters of the equivalent circuit R naught, X naught, R naught 1 or R naught 2, X naught 1 or X naught 2. On the second one is the voltage regulation. On third one is iron loss and copper loss. So if you know the iron loss and copper loss, so then we are going to calculate the efficiency of the transformer. So we will see the first one is the open circuit test or no load test. So the main purpose of open circuit test is to determine the following parameters. So the first one is the iron loss that is indicated with the WI. So the second one is no load current that is I naught. And the third one is the equivalent circuit parameters. So R naught and X naught. Already in the initial itself, I said, so with the help of OC and SC test, we are going to calculate the equivalent circuit parameters on voltage regulation. And the third one is iron loss and copper loss. So when you are talking about only the open circuit test, the purpose of open circuit test is to determine iron loss that is indicated with the WI. And the second one is no load current that is represented with the I naught. And the third one is equivalent circuit parameters. So what are the equivalent circuit parameters? Is nothing but R naught and X naught 1. So this figure shows that the pictorial representation of the open circuit test or no load test. So from the figure we observe that it having one transformer, one auto transformer and three meters. So one is the voltmeter and second one is the ammeter and third one is the wattmeter. So these meters are used to measure the corresponding readings. For example, if the voltmeter are used to measure the voltage, so ammeter are used to measure the current and wattmeter are used to measure the power. So what is the need of auto transformer, the single phase auto transformer here? And so what about this transformer? So this entire figure shows that the pictorial representation of the open circuit test or no load test. So if from the figure, if we observe that, so the low voltage winding of a transformer is connected to the supply of the rated voltage and frequency. So if you observe this figure, so this transformer it having two windings. One is the low voltage winding and second one is the high voltage winding. So this low voltage winding of the transformer is connected to the rated voltage of the supply and its frequency. So its secondary winding is kept to open. That's why it is called as open circuit test because here there is no load. There is no load. That's why it is also called as no load test. Try to understand clearly from the figure. If you observe that it having one normal transformer, one auto transformer. So on it's having three meters. One is the voltmeter and second one is the ammeter and third one is the wattmeter. So these meters are used to measure the corresponding readings. The voltmeter are used to measure the voltage, ammeter are used to measure the current and wattmeter are used to measure the power. So this transformer having two windings, one is the low voltage winding and second one is the high voltage winding. So the LV winding is connected to the rated voltage of the supply and its frequency. Its secondary winding is kept to open. So here the single phase auto transformer is used to set the rated voltage. So this especially the single phase auto transformer is used to set the rated voltage. So here the rated voltage we are giving that much voltage we are going to set with the help of this auto transformer. So initially it is there in the zero position. So once if you are varying slowly this auto transformer until you reach the rated voltage, that is 220 or 230 volts. So once it is reaching to the 230 volts or 220 volts, then we have to stop the varying. So once it is reaching 230 volts, then the corresponding readings we have to measure. What are the corresponding readings means? So the ammeter will measure current and the wattmeter will measure the power. So the same thing here I said. So if you observe the figure, the low voltage winding of a transformer is connected to the supply of the rated voltage and frequency. So on the high voltage winding of a transformer is kept open. So here the single phase auto transformer is used to set the rated voltage, that is 220 volts or 230 volts. And then once if you are setting the rated voltage with the help of the single phase auto transformer, you have to measure, you have to note down the corresponding readings of the ammeter and wattmeter. So here the ammeter will give the no load current that is indicated with the I0, and the wattmeter is indicate power. So this ammeter will give the no load current. The no load current is about 3 to 5% of the full load current. So here the copper losses will be negligible because there is no load connected here. So therefore the reading of the wattmeter will indicate the iron losses of the transformer. So the equivalent circuit parameters R naught X naught of the transformer can be calculated as follows. So how to calculate these R naught and X naught of the transformer parameters? So input no load, input power on no load, that is indicated with the W naught is equal to V1 I naught cos pi naught. This entire thing is nothing but iron losses. So V1 is your rated voltage, I naught is meter current, cos pi naught is the perfect reading. So where V1 is the primary voltage because the LV winding of the transformer we are connected to the rated voltage. I naught is the no load current, cos pi naught is the no load power factor. So from the no load power factor, if you observe this equation, so we need cos phi naught. Cos phi naught equal to W naught divided by V1 and I naught. So the same thing here. Cos phi naught is the no load power factor that is equal to W naught by V1 and I naught, where V1 is the primary voltage or rated voltage. I naught is the no load current that will give the ammeter. So from the value of the power factor, the no load current I naught having two components. So the first one is the active component or working component that is indicated with the IW. And the second one is the magnetizing or reactive component that is indicated with the I mu. So this figure shows that the active component or magnetizing component both are represented here. So the active or working component IW equal to I naught cos phi naught. So if you observe this figure, so I naught equal to IW plus I mu. So they are telling that the no load current is having two components. One is the active component that is indicated with the IW, and another one is the magnetizing component or reactive component that is indicated with the I mu. So while getting these two components, we will get the no load current. So the active component or working component IW equal to I naught into cos phi naught The magnetizing or reactive component I mu is I mu equal to I naught into sine phi. So already we know that I naught. Already we know that cos phi naught. So based on these two parameters, we are going to calculate active or working component or magnetizing or reactive components. So I mu equal to square root of I naught square minus IW square. So this is the equivalent circuit on no load. So I naught having two components, one is represented with the IW, another one is represented with the I mu. So the equivalent circuit parameters. So we need to calculate the equivalent circuit parameters. In CL itself, we said that the open circuit test and short circuit test are used to are helps to determine equivalent circuit parameters, voltage regulation, iron loss or copper loss for calculating the efficiency. That is combined of OC and SC test. So when you are considering the only OC test, we are going to calculate the following parameters. One is the no load current, and second one is the core losses or iron losses, and the third one is the equivalent circuit parameters. Those are R naught and X naught. So already we calculated I naught and iron losses. How we are calculated I naught or I naught and iron losses means with the help of auto transformer, we are setting the rated voltage. Once if we are setting the rated voltage, the meter will give us the rated current and the wattmeter will give us the iron losses. So the third parameter, we have to calculate the equivalent circuit parameters. Those are R naught equal to V1 divided by IW and X naught equal to V1 divided by I mu. So while knowing these active working component, we are going to calculate the R naught. So if you know the magnetizing reactive component, then we are going to calculate the X naught. So one major note, if the measurements are made on HV side, then the voltage required is to applied would be large and the current would be inconveniently small. So the same connections, if you are given in the HV side, then the voltage required would be large and its current is very small. Inconveniently, it is very small. So now we done on the primary side. In the same connection, we can also give in the secondary side also. If we are giving the connections on the secondary side, then you need large amount of the voltage. So this is about the OC test, open circuit test.